Okay, this is the third video for the material from section 1 of chapter 1. Next thing we've got to go over is a few postulates. As we stated at the end of the last recording, we have a postulate as a true statement that is accepted without proof. Now the name for a postulate is axiom. So the first of the postulates that we state for geometry. Through any 2 points there is exactly one line. So I've drawn 2 points selected at random, and anytime you have 2 points there's exactly one line, one straight line that can contain those 2 points. If you tried to draw a different line that contains those 2 points, it would have to have a curve, and therefore it's not considered to be a line, not as far as geometry is concerned. So therefore there's exactly one line that contains those 2 points. Exactly one is a very key phrase in geometry. It means there is one, okay, that one does exist, and exactly one means that a second one does not exist. Okay, so there is one line that passes through points A and B, and there isn't a second or third or fourth, etc. Next postulate. Through any 3 points there is at least one plane. Through any 3 non-collinear points there is exactly one plane. So the first part of the postulate states that there is at least one plane. There could be more than one plane if the 3 points are collinear, such as in this diagram. Okay, let's consider points A, B, and C where you might find the staples, say, for the seam of a magazine. All of the pages of the magazine, if they had absolutely no thickness like an actual plane, they would all contain points A, B, and C. So all of the pages inside the magazine, all of these pages, all of those planes, all contain A, B, and C. So therefore there's at least one plane. There's numerous planes that contain those 3 points. Technically there's an infinite number of planes that contain those 3 points. But if we start with 3 non-collinear points, such as in this diagram, if we had 3 points, say on a sheet of plywood or on the floor of the classroom, okay, those 3 points all lie on that one flat surface, that one plane, plane X in this diagram, and it's impossible for a second plane to contain those 3 points, points R, S, and T in this case. Next postulate. If two points lie in a plane, then the line joining them lies in that plane. So if we had 2 points on the floor of the classroom, then we tried to draw line AB, it is also going to be on the floor of the classroom. It's not going to, say, come up through the floor at point A and curve back down and go out through the bottom of the floor. That's not possible. Obviously, the second line does not exist. The first line does exist, and it's the only such line. Okay? And it has to be on that plane. Next postulate. If 2 lines intersect, then the intersection is a point. So we can exactly one point. Okay, a lot of times it's easy to say there is a point, but we have to be precise and say it is one and it's the only point where they intersect. So if we draw 2 straight lines, you can see that it's impossible for the second line to intersect the first line at more than one point, no matter how far you extend the lines. So there's exactly one point any time 2 lines intersect that they have in common. If 2 planes intersect, then the intersection is a line. Specifically, the intersection is exactly one line. So let's consider a box-shaped figure, such as the classroom. We have 4 walls, we have the floor and the ceiling. Right now I have illustrated the front wall of the classroom and the wall on the right-hand side. And you can see that those 2 walls intersect along the seam in the room, or the seam of the box. Because the planes extend forever, that set of points that form the intersection extends forever, and therefore the intersection of two planes is a line. And it's exactly one line. Hopefully all of this helps. Good luck.